Hi guys, and welcome to Activity 3 in the Year 8 Physical Sciences course. In this activity, what we're going to be looking at are the different types of energy. What we're going to do is give a basic definition as to the various types of energy that we use a lot in the science courses, so that you've got a familiarity with what they are. Later on in the course, we'll actually go through individual ones in a little bit more detail and how we can calculate them, etc., etc. Okay, so let's get started. So there's many different types of energy. Now remember that energy basically is where work is done on a system. So there's lots of different types because there's lots of different types of work that goes on. Now the first one that we're going to be looking at is kinetic energy. Now kinetic energy is the energy that is generated when an object is moving. Now if an object is moving really, really fast, then as a result it's going to have more energy than an object which is moving really, really slowly. Don't get into the idea that it's going to cause more damage, because it doesn't necessarily work along those lines, because there are other variables that you've got to take into account. But work on the idea that if an object is moving very, very fast, then it's got a lot of kinetic energy. And if you can keep that in your head, then you're going to be fine on this. Now, basically, instead of kinetic energy, often what you'll see is Ke. Sometimes you'll see it written with an energy with a subscript of a K. E standing for the energy and the K standing for kinetic. It depends what you're looking at in different types of the world. So, kinetic energy, moving energy. If we look at the next one, which is gravitational potential energy, or GPE, this is the energy which is generated when you lift an object above the ground. Now, potential energy basically sort of says that it's stored, it's there, it could happen. So if you stand on a chair, you have the potential to fall off. Now, if you jump off a chair, you know that work is going to be done on you. Now, if you go up a skyscraper and jump off, God forbid you wouldn't do that, but if you were to do that and land on the ground, you know that it's going to cause you a lot of damage. Why? Because you have got so much energy, the ground will resist you. Work will be done on you to stop you. So as a result, if you raise something up a certain height, when you jump off, you will notice that you've now got that stored energy has been converted. Now, in a lot of cases, that energy is going to be converted into kinetic energy. Okay, and we'll talk about that energy transformation later on in the course. But for now, just understand that if you raise something up, for example, this clicker, if I raise it up a certain height, then it's going to generate a certain amount of energy. It's got the potential to fall. Now, if I only lift it a certain way, it's only got a small amount of gravitational potential energy. If I lift it higher, it's got more potential energy. And you may have heard that if you take something like a coin up onto the top of a very, very tall building, let's say the Empire State Building, and you drop a coin off the top of the Empire State Building, it's enough to kill somebody and on the ground. Why? Because all that gravitational potential energy is converted into kinetic energy. And so it's moving incredibly fast when it gets to the bottom. So it's almost like working like a bullet. So you get the idea that we've got this idea of gravitational potential energy. Now, going back to our kinetic energy, you know I said that you can have fast energy and you can have slow energy. Now, showing the idea of gravitational potential and kinetic energy, imagine a bicycle. Put a bicycle on a hill. Let's say the hill's that high, so it's got a certain slope. Now, it's got gravitational potential energy at the top. If you were to stand at the bottom, that gravitational potential energy would be converted into kinetic energy, and you try and stop that bicycle, you're going to get a big ouch factor. But what if the slope was very shallow? You don't have a lot of gravitational potential energy, you don't have a lot of stored energy, and I'm not talking about pedaling, I'm just talking about rolling down a hill. So as a result, you'll be able to stop that bicycle when it gets to you down the bottom here, because you haven't got very much energy. So hopefully you get the idea of energy being converted from one type to another. So we've got kinetic energy, moving an object, and then we've got gravitational potential energy, which is the energy which is stored by raising it above the ground. Remember, it's going to be under the effect of gravity, hence it's gravitational potential energy. Another type of potential energy is elastic potential energy. Now, you pull back an elastic band, a rubber band, you pull it back halfway, you've got a certain amount of energy. You pull it back a long way, you've got a lot of energy. I'll tell you what, take a rubber band, go up to somebody and pull it back only halfway, and they might go, ooh. You pull it back all the way, they'll start doing this. Why? Because already they know that if you let that go, all that elastic potential energy, lots of it, can be converted into a big ouch factor when it hits you. Why? Because your face is going to resist. It's going to do work on that rubber band. So as a result, it's going to hurt. So pull it back a wee bit, not a problem. Pull it back a long way, huge amounts of stored energy. Result is it's going to be quite painful when you hit it. Same with a bow and arrow. You pull it back a long way, a short way, it's not going to go very far. You pull it back a long way, it's going to go a long distance and do a lot of damage. Okay, so again, we get the idea of this potential stored energy. Now, something is also classified as elastic if it can go back to its original shape. And a good example of that is bungee jumping. As we know, extreme sport, basically you're going to jump off a bridge with a rope tied to you. Yeah, probably not the smartest thing to do, but hey, people like to do it and they'll pay for it. So that's really quite interesting, but that's another story. You take a bungee rope, it's got elastic. What will happen is it will stretch, and as it's stretching, it's actually beginning to slow you down. But the gravitational potential energy determines the speed at which you fall and the extremeness of your bungee jump. So remember, elastic will pull you back to its original shape. So if it's only a certain length and you're a certain weight, they can calculate whether you're going to hit the bottom or not. Obviously, you don't want to hit the bottom, but it will expand up to a certain point and then go back to its normal shape, hence it's elastic. So hopefully that explains elastic potential energy. Next one we've got is chemical potential energy. This is the energy which is stored in the bonds of a chemical structure or a chemical molecule. Now, this is harder to understand, but think about food. You go to McDonald's, you eat a burger. That has got potential energy because you eat that burger, and if you're not sick, you store that energy inside you. So that burger has got lots and lots of energy, and by digesting it, it will get laid out in your body, and it will be utilized as and when your body needs it. So it's got chemical potential energy. If you don't believe me on that one, then take some oil, take some petrol, light a match, throw the match on it. It burns. Why? Because the chemical energy is being released. It's being released into the form of heat energy. So it's the energy which is stored, hence potential, in the chemical bonds of the molecule. And we use that all the time. Next one we've got is nuclear energy. Now this is the energy which is stored in the nucleus of the atom. So chemical energy is between the atoms. Nuclear energy is the energy which is stored in the actual center of the atom. And if you are unaware of what the nucleus is with respect to atomic structure, go and look at my chemical theory course on the St. Hilda's catalogue, and the chemical theory course will run through all atomic structure from year 8 all the way through to year 10, so check that out. So nuclear energy is the energy stored inside the nucleus of the atom, which can be released. And this is what a nuclear reactor does. It allows us to actually release that energy, which is converted into heat, and from that we are then able to convert it into electrical power. So again, it's the potential, it's there. It's not going to be released all at the same time unless we control it. Now you think about an atomic bomb, a nuclear weapon, you can see the amount of energy which is released when lots of it is released at the same time. And the bombs of Hiroshima and Nagasaki at the end of World War II show us, the videos show us how much energy can be released in a very small amount of space with a certain amount of nuclear fuel. So nuclear energy, is the energy which is generated when we split the nucleus of the atom itself. Sound energy, that's the next one. Now, sound energy is basically a vibrational energy. It's the energy which comes when an object is hit and causes it to vibrate. And what happens is those vibrations then resonate in a sensor which we hear as sound. So when my talking at the moment, there are going to be speakers which are going to be vibrating. And as they vibrate, they are pushing air or sucking air back in, and that's resonating on your eardrum, and your brain is hearing it as an electrical signal stating, that's a specific sound. And by putting all the sounds together, we get this idea of conversation. We get the idea that you are hearing what I'm saying, and hopefully you're understanding it. So sound energy is a vibrational energy, and as you can see here, you can get that by banging any object. Heat energy. Now, heat energy is often a byproduct of a transfer of energy. For example, if you're taking a fuel such as petrol and you light it, the little bit of heat is a catalyst, something that gets things going to put a huge amount of energy release. So often heat energy is a byproduct. Now, sometimes we use it and sometimes it's a problem. In a car, it's a problem. We don't want heat because we want movement. We want kinetic energy from the chemical energy of the petrol. But in something like the oil of when you're cooking, then that heat energy is very, very important. So basically what we've got here is a situation where heat can come off, and it can either be useful or it can be not useful. But it is directly related to the amount of energy an object has. The more energy it's got, the hotter it's got. The less energy it's got, the less hot. There is no such thing as cold, and we'll talk about that in the Year 9 unit, which will be coming up later. So heat energy is basically how hot an object is. Now, another product of energy transfer is light energy. Light energy basically comes off as different frequencies, and those different frequencies can combine together to produce white light. For example, when you look at the sun, you say that the sun is white. Why? Because we've got lots and lots of different light energies coming off. Now, this is basically due to vibrational energy which is occurring in the actual atom itself. And that's a year 11 or 12 physics study, so we won't talk about that in any great detail. But again, light energy can be a byproduct of an energy transfer system, and again, we can utilize it. So what you need to do is to be able to explain what each of those energies are, and from there be able to link them to various systems and say what's going on. In Year 8, you don't need to know anything in any more detail except for the units that I'm going to be putting up on this course. So thanks for watching, and join me again in the next unit. Oh, sorry, electrical energy. I forgot that last one. Electrical energy is the energy of moving electrons inside a wire. So often these are generated at a power station or in a specific generator, and it's the movement of those electrons through a conduit, which we call a wire, and basically the quicker they're able to move, the more energy that they can give out. If they're slowed down, then energy may be given out in the form of heat and light, for example, an incandescent light bulb, and then the result is that we can utilize it. So sorry about that, yeah, hope you get the idea as to what those definitions for each of those energies are, and yeah, join me again in the next activity. Thank you for watching.